Today we're reviewing the Anycubic Kobra 2 and we're going to continue where we left off and build a successful sock knitting machine. So let's start at the beginning. So I've literally just unboxed this Anycubic Kobra 2. I slapped it together and on the SD card there was some benchy files, so I just clicked play. I didn't do any of the setting up, no calibration, no E-steps, no leveling. It's done it all automatically and gave me a benchy in 30 minutes. This is the 30-minute benchy at 0.3mm layer height. It's now exactly halfway through another benchy, that's at 0.2mm layer height. Total time at the moment is 20 minutes. So we'll let this benchy finish and then we'll have a good clear look at this machine, see if it's worth our money, shall we? Just while it's running, I'm getting 62 decibels of noise, which is actually exceptionally quiet considering the fan is front and center. Cooling is really important with these machines and it's going to improve the printing time. Just looking at the back side here, we've got dual Z-axis rods. So for high-speed printing, this should stabilize everything really well, make more accurate printing. You can see they're connected by a timing belt at the top. We've got a little module here for filament runout detection. You can see we've also got the motor on the print head. That's a direct drive. Direct drives are also really important for accuracy and great for printing things like TPU. We've also got a new style of bearing system that they've started using on these machines. I first noticed this style on the xTool D1 laser cutting machine. As you can imagine, the plastic wheels tend to wear out over time, so these will remain more accurate for longer, I guess. We've still got the plastic wheels on the sides though. The touchscreen also is very clear, there's nothing complex about it. It's also been quite intuitive to use. Yeah, so far so good. What I believe these are probes for the nozzle. So if you ever change a nozzle to say a different type, this will automatically detect the nozzle and gauge the height for you. Well, there we go. Now I really love these metal build plates because all I have to do is straight off they come. So this one took 40 minutes in total at 0.2mm layer height. That's just with my standard black PLA. There you go, that's the difference between 0.3 and 0.2. So because we're doing mechanical parts now, I've whacked on a spool of PLA+. Now PLA+ has better printing qualities and structural qualities compared to regular PLA. Anyway, I've made some adjustments to the sock knitting machine, and just using the standard settings, it's got 4 hours and 47 minutes print time, which to be honest, isn't that bad. Alright, let's print it out. I've just come back to check on it and oh my goodness. So that's probably one of the most cleanest prints I've ever done. That is a flawless finish on the base. I've just got to take this brim off. So the main modification I've done is I've added height to this central part here. I've made the wall thickness a lot thinner to save on using material, but I decided to keep the strength in this part here. Alright, so let's take the old one apart. Well, it looks like I have to print this out as well. Alright, moment of truth. Now I need to put some yarn through it. Haha, it's working! So I'll show you how to start this in a minute, but let me just show you the progress I've made so far. Oh, come on. So what you just saw there's the gears slipping. This isn't quite fixed on properly there. The bearing keeps pushing itself way out. So this is my next fix. I'm not going to use gears at all. I'm going to do something very different. But I'm pleased with that. Come and have a look. So this is just hanging off a weight at the moment. But look at that. My toes are going to be cozy. So I think I'm ready to start to do the final design now. Right, so a worrying amount of hours later, I've come up with this design. It's completely done from scratch. There is nothing original on this compared to the other one. So I guess we'll start printing and see how well it looks in real life. Right, so the first part I'm printing is the cylinder, which holds all these little tiny hooks. The only problem is I see bulging on these very sharp edges. Couldn't quite find a setting on Prusa Slicer to stop that. I know you can do it in Cura, but I couldn't find it. This part takes 11 hours, so it's an overnight job. We'll see how it is in the morning. Alright, here we are, next day. So far, that is incredible. Tiny bit of stringing on the inside, but that's minimal. So what I designed differently about this is I gave it some rounded over top, and also this edge here has a slight curve on it also, because that's where the yarn is kind of being pulled over, so I wanted that to be as smooth as possible. If we look at the original design, the fixing points are just those little tabs at the bottom. I've changed mine to have screw holes at the very bottom, so there are 0 snag hazards on that yarn. Does a hook fit it though? Well, I actually thought it was going to be a lot tighter than that, so minimal sanding. So we're halfway done on the next print, and what I'm doing with this is using a jigsaw blade and kind of going through all the little crevices like that. You can see here on one that I've already sanded, it's got nice movement. Haha! Oh, so satisfying. I've still not finished sanding this yet, but let's just see. Ooh, yeah! Oh no. Right, so it might be that this is too acute of an angle. I'll have to put some epoxy putty or something there just to ramp that up a little bit. I'll have to fix that on the main design as well. Right. So this winder piece is meant to have some bearings pressed into it. So I thought, why not try this on the 30-ton press? There we go, I'd say that's done it. So I've just reprinted what I'm calling the Raceway. I did it out of black this time because I've run out of green. But I've noticed I've made a major mistake on this too. This poor kid's got an awful case of acne. That's because I eventually plucked up the confidence to change some settings. If I click on View Seams, you can see they're literally dotted randomly all over the place. So if I go on to Seam Position, I've got it on random. I think that's because I was trying to hide the seams on one of the pieces I was creating. So if we switch that to Aligned, now all of those little stop starts have disappeared. And you can see these little white lines, it's now moved it to corners. So overall, that will make the print a lot more cleaner. However, I've done it now, so let's see how it works. Right, so now I've got some plywood here. This is 11mm thick. This is going to be the base plate, and what I'm going to cut it out with is my xTool D140 watt. Now, if you haven't got a laser, that's absolutely fine. You can cut this out by hand. It's not a complicated shape, so a jigsaw would be absolutely fine. But if you're thinking about getting a laser, this is what I would recommend. And if you like, I'll leave my review to this at the end of the video. So that took 7 minutes. Did it cut properly? Nah, needed just a couple of more passes. That was a shame. Well, I would say that's not bad otherwise for 7 minutes. Just a little bit of a clean up on those edges and we're good to go. Alright, so this is a little addition that I added. This here is a holder for the counter. Oh, perfect fit. This has a magnet sensor that slots in there. So I've got to trim the wires to size, but essentially you have a magnet that you attach onto the sock maker. Every time it does a full rotation, it goes past this sensor. And this enables you to count every line of stitch so you can make them all the same. I believe it's time now to attempt the assembly. So next I needed to tap the wooden base here. I needed an M8 tap, but I didn't have one, so I just made one out of a bolt. You can see I ground it to a taper and then just scored a few lines using a 1mm cutting disc. For wood, that is just fine. I've reused the handle off the old one. Make sure we put a washer down. Perfect. So to connect these two, instead of using gears, I'm using TPU transmission belt. So what I'm going to do is just lay it over. So whilst pulling it fairly taut, not too taut, I'm going to cut it roughly 20mm or an inch short. There you go, this is our belt cut to length now, and all I'm going to do is fuse these two ends together. So I'm going to show you the crudest way of doing it, and that is just simply using a lighter. And the idea is not to burn it, but just to melt it. So I don't know if you can see that, but I'm just watching the ends go nice and glossy. I'm going to just hold them together until they've fully cooled, and then we'll trim off the excess. And so for that I'm just using a pair of side snips. So I could sand down that last little bit, but it's not necessary. So now I should be able to just slip this on here. There we are. So the question now is, will it knit? And this is the answer to that question. This is a combination of my own incompetence and some issues that I found with the machine. So this is the stage that the machine is as of now. You'll notice two things that are wrong with this. One, that I've crossed over the belt here, and I've also added this retainer clip for the guide there. And this is because these belts are simply no good. They don't grip it enough. So I've got a fix for this, but I'll show you what's wrong with the printer first. So the quality of the print started declining a lot. You can see here, that is looking awful. And things that were meant to be printing straight are now started to have a bit of a lean on the go. So I thought that's not a problem, it's probably come out of level. So what I'll do is I'll click in the auto leveling sequence. When I did the auto level, after it homed, it would go to where the probe was and then it would just strain the motors. Eventually it would stop and it would say there's a problem, it can't find the probe. And after trying to do it manually, I got in touch with Anycubic. They were actually really helpful. They sent me a whole PDF with all the possible things that could be wrong, and it turns out that it is a common fault. What I ended up doing is dismantling the probe and having a look inside. And what it actually turned out to be was a slight loose connection within the probe. After I assembled it back together, it all started working fine. However, I didn't pay attention and the nozzle actually dug into my bed once I tried to do a test. And you can see it's completely ruined the surface of it there. What I should have done is kept an eye on it and adjusted the Z height as it was doing its thing. It should have automatically calculated it. I don't know why it didn't in this case. Anycubic were very understanding though. They're sending me a new build plate and they're offering a brand new machine for the raffle. So this is working absolutely spot on now. So if you would like a chance to win one of these, support my channel and contribute to an awesome charity for just £5, then there'll be a link in the description. And today's charity is Compassion International. What they do is they create support hubs in some of the most deprived areas of the world. And then what they try to do is link individual families with sponsors around the world. So for example, we support a little girl and her family in Colombia. And my daughter sends messages back and forwards with her and we send them some money every now and again to help with the things that they need. And I strongly believe that by helping an individual and having that direct contact can make a world of difference. I've seen testimony after testimony of people who have been through the Compassion Network able to re-establish their lives and get themselves out of poverty. They're an absolute inspiration and I really want to support them further. But anyway, how are we getting this to work then? So the TPU belt was a good idea, but it's not right for this application. So instead, I'm going to use this, which is a timing belt for 3D printers. Obviously there's a link to all of these things in the description. And after a bit of trial and error, I've managed to get the teeth just perfect now. So this should now coat with my man hands and shouldn't slip at all. But anyway, I'll dismantle this and install these now. So now we're assembled, it's time to splice the belt together. So I'm going to lay this piece over. And what I'm measuring there is about 20 millimeters of overlap. So I've got a cutting board here and a craft knife. And on the board I've marked 20 millimeters. So what I need to do is lay down my piece here. So it's from that point there. I'm going to cut in ever so slightly. And basically I want to go along the length, cutting off all those teeth. There you go, until you got something like that. Now on the opposite side, what we want to do is just remove some of this rubber backing. So again, marking the 20 millimeters, going to make a slight cut and working our way across the length. And then when you've gotten it down to those fibers, then just give it a quick sand over. So now all that's to do is just to dab a little bit of super glue and bring those two halves together, making sure that they are equally spaced apart. So you might want to start off at one of the tips and then work our way across the length. And there we are, that is now successfully spliced. And even though it's super glue, it's still got good flexibility to it. So to attach the belt, we now need to take off the winder. So there, now we can slip the belt on and reposition it. Now, if done correctly, you will have a bit of slack. And if we try to turn it, it will just slip. So we need to add a belt tensioner, which I've just printed here. So let's assemble this. So to assemble it, we're going to add one of these standard bearings. These are Abec 9 skateboard bearings that I've used throughout the whole assembly. You want to add a washer top and bottom and just slot it in here. And on the underneath, you'll notice there's a little hex slot for a nut. And that's going to accept this M8 25mm bolt. So that should now sit flush and spin freely. Now on the opposite part, we've got something similar. We're going to slot this nut into here. And then on the opposite side, we're going to slot this 35mm M6 bolt. And so now if we slot the two together, you can probably see how it works. You twist this, which extends this. So let's fit it to the machine. So being careful not to get in the way of the handle, I'm going to mount it here. So keeping the back of the tension against the side of this plate here, I've got two very small screws to attach it with. And if this is loose enough, this should just slot in underneath the belt there. And now it's a case of just tightening this bolt until you've got the correct tension. You could probably add another nut there just to lock it off with. Right, so now that is a lot better. However, we're not quite finished yet. I want to add a retaining clip here. And to do that, I've got these tiny little threaded inserts. They work by just positioning them over the hole, like so. And then you push them in using a soldering iron. There we are. And another one here on the other side. Perfect. So now I can insert my guide and screw on the retaining clip. And those inserts will make sure that there's a strong connection there always. And the very last thing to do is to pop our magnet back into place here. Done. Now will she knit? Right then, let's make a pair of socks. I've cleaned my hands, by the way, because I'm actually a blacksmith pretending to be a tech enthusiast. But remember, dirty hands, clean money. So to start the sock off, we need a weight. This is 4.5 kilograms. Now you could use any kind of weight, but I recommend getting hold of these magnetic hooks. And I'll demonstrate it here. This luggage scale goes up to 32 kilograms. And if I pull on this magnet with all my weight, you can see we take on the maximum. Well, there you go. I bent the hook before the magnet release, so I can absolutely rate these 100%. And on the ceiling above my sock making machine, I'm going to put a hook here. Now for £7, I also bought this yarn baller. That way I can actually recycle the yarn that I've used quite easily. But the way these work is that you pull the yarn through the middle. So I'm going to take the end and loop it over the hook there. And then I want it to come down through the back of the hole on the top of the machine here. Reach down from underneath and pull it down through there. So now I'm going to take my weight, I'm going to take the end of the yarn and just tie a little knot on the end of it. So now I'm just going to hold it on my knees just below the machine like that. So this cylinder can actually take 80 needles, and you'll notice that I've only filled half of these up. And basically that will determine the size of your tube depending on how many needles, therefore how many stitches you're going to make. These needles are also in the description if you want to get hold of some. So to start it, we're going to take the yarn in the middle, just slightly pulling on the weight, and we're going to start hooking on one of those needles and then pull it back down to the hook on the weight. And then I'm going to keep repeating every other needle. So once you've connected to all the needles you can get hold of, we can just turn it a little bit and expose a few more. I'm going to bring this back and do the rest over here. There we are, they're all connected. So my guide is on the left hand side of my yarn inlet here. So that means I need to go clockwise. So let's begin. And so you can see it's automatically grabbed hold of the other needles now. I've done 5 rows now, so I'm going to count another 30, I think. So frustratingly, I've lost the footage of me trying to make a heel and removing it from the machine. But what was essentially a few minutes, I've created this. Not quite the sock you thought I was making, was it? Now, unfortunately, with this machine, you can't actually form a heel properly. Now, for those who know how to make a heel, I thought it could be done by switching the guide to the opposite side. Turns out you can't, so I'm gonna have to rethink the whole design again. So knitting might not be the manliest of things, but it was definitely men that industrialized it. So why does building a machine like this fascinate me, might you ask? Well, in today's modern age, there is a massive call for natural fibers. But what isn't good is that farmers are having to lose money when producing wool. So it'd be super awesome to produce machines, micro machines, that can produce fibers from wool straight on a farm. But if you guys would like to develop this further, download it for free via Thingiverse. And if you want to leave a donation, I'd be very appreciative. Otherwise, why not join the raffle and win one of these machines? Because to create this in about 2 minutes, it's actually taken me about 2 weeks. I've spent far too long on this now, and I actually really want to build my steam engine. And that's with the idea of making energy far more self-sufficient. So check out that episode when it comes. And so can I encourage you to be a doer, not a watcher, and get out there in the real world and forge for yourself a life worth living. See you in the next episode. Bye-bye.